In this lecture, we'll see how to solve the LPP using the graphical method. There are simple steps to follow. The first is to plot the constraints. The next is to shade the common feasible region. The next is to find the feasible corners. The next is to evaluate the objective at the feasible corners. Then choose the maxima or minima, whatever is asked. Let's take up an example. Let's say the LPP is maxima is z equals to 6x1 plus 5x2. And the constraints are x1 plus x2 is less than or equal to 5. The next is 3x1 plus 2x2 is less than or equal to 12. And the non-negativity constraints. Okay, so these are the constraints. Let's say this is the blue constraint, this is the red, and this is the yellow constraint. Yellow constraint is the non-negativity constraint. So the first step is to plot the constraints. Now to plot the constraints, let's take up the blue constraint. To plot, treat this less than equal to. Just for plotting, you treat this as an equal to. That means you plot the line. Instead of the region, what you do, plot this as a line. Plot this as a line. Okay. So the constraints that are given, first you plot them as lines. The yellow constraint says that all the variables, both of them are non-negative. So that is why we have to just focus on the first quadrant. So x1 and x2 both are non-negative. So if x1 is non-negative, the region is this. This is the region because it says x1 is non-negative. This. The entire first quadrant. The second constraint in the non-negativity says that x2 is also non-negative. So x2 means y. So y is non-negative means you are there. So that is why we are in the first quadrant. Okay. So we have plotted the yellow constraint. Now let's say we plot the blue constraint. This is the constraint. So first plot it as a line. So how do you plot? If you want to plot this line, it's a straight line passing through 2 points. You need 2 points. So let's say you put x2 as 0. So what is x1? x1 is 5. So point is 5 comma 0. And the other point is if you put x1 as 0, you get plus x2 equals to 5. So x2 equals to 5. So the point is in fact 0 comma 5. So once you've drawn the 2 points, just simply pass a line between these two. So this is the blue constraint as a line. Now you decide which side of the region you should be. See, there is this side facing towards this origin and there is another side facing away from the origin. So there are two possible cases. Now, which one amongst them should you choose is the question. How to decide that? When you want to choose which side of the line you have to be in your feasible region. So what you can do is follow the step that if you want to choose, so what you can do is put 0 comma 0 in the constraint, the original constraint, not the line. Put 0 comma 0 in the constraint and see if 0 comma 0 satisfies the constraint. If it satisfies, that means if 0 comma 0 satisfies, this implies region is towards 0 comma 0. So you can use this fact to check for your region. So what do? We put 0, 0 in this constraint. So 0 plus 0. So overall, the left hand side is still 0. And 0 is definitely less than equal to 5. So that means 0, 0 is satisfying the inequality. So if it satisfies, the region is towards the origin. That means you have to look this side, facing towards. So this is the region towards this origin. Now plot the second red constraint. So for the red constraint, what you do? You solve this equation, plot this line. So let's say this is 0. So what is x1? 3x1 is 12. So x1 is 4. So x1 का value आ गया 4. So the point is, say this 4, 0. For the next point, put x1 as 0. So twice x2 is equal to 12. So x2 equals to 6. So x2 is 6, यानी कि 0, 6. So pass a line between these 2 points. So this and this. So this is in fact the red constraint. So just let me color this red. So this is the red constraint. Now इसमें कैसे decide करना है? If you should be towards the origin or away from the origin, put 0, 0 in place of x1 के place पे 0, x2 के place पे 0. So overall this side is again 0. So 0 is less than 12. It is true. That means you are towards the origin. So towards तो यही है. Now we have plotted every constraint in our problem. So where is the common region where everybody is agreeing? The region where everybody is agreeing, where you see a red arrow, a blue arrow, a yellow arrow. So this is the feasible region. Why can't this be the region? ये वाला पॉइंट क्या feasible हो सकता है जो यहाँ पर है? ये feasible क्यों नहीं है? क्योंकि इस पॉइंट के लिए blue constraint is not satisfying. क्योंकि blue is saying to be below this line. So ये पॉइंट चला गया, यानी कि ये पूरा रीजन ही साफ हो गया. ये नहीं होने वाला. क्या ये लाइन, क्या ये रीजन हो सकता है? दिस रीजन ऑल्सो कांट बी देयर, क्योंकि इसमें रेड मना कर रहा है. ओके, इस रीजन में ऑल दी कंस्ट्रेंट्स आर एग्रीइंग. नॉन नेगेटिविटी भी है क्योंकि आप फर्स्ट क्वाड्रेंट में हो. आप रेड के भी इधर ही हो, आप ब्लू के भी नीचे हो. सो द रीजन that everybody is agreeing to is in fact the region this boundary, this boundary, and everything that is inside the boundary. So this is our feasible region. Now we have drawn the feasible region. The next step is to find the corners of our region. See, the corners are, see this 0, 0 origin is a corner, 4, 0 is a corner, 0, 5 is a corner, and this point is also a corner. Okay, because here the constraints are meeting. Now this point is, let's say A, that is 0, 0. Let's say this is B, 0, 5. Let's say this is D. Let's say this is C. So what is the point C? The point C actually lies at the intersection of the red constraint and the blue constraint. That means इसको और इसको आप solve कर लो. So how to solve? You solve, multiply the first by 3 and subtract. You get x1 equals to 2 and you get x2 equals to 3. So this is the point. How to solve? Solve these two. Multiply this by 3. This becomes 3. This is 15. Now subtract. This is x2. Subtract. So get 3. So that is x2. Okay. Put this x2 in the any first constant or second, you get the value for x1. So this is how you get the corner C. So these are the 4 corners. The final step is to list the feasible corners. Corner A, corner B, corner C, corner D. This is the corner. A is 0, 0. B is 0, 5. C is 2, 3. D is 4, 0. So at each of the corners, evaluate your objective. The objective is to maximize Z equals to 6x1 plus 5x2. So this is the objective. So put 0, 0 in the objective. The answer is 0. Put 0, 5. X1 is 0, x2 is 5. So you get 25. Put 2, 3. So you get 27. Put 4, 0 in the objective. So you get 24. Now since the objective is to choose the maximum, so among these four values, what is the maximum? 27 is the maximum. Occurring at what point? 27 is occurring at 2, 3. So in this region, what in fact becomes the optima? This point C is the point of optima. This is the point of optima. So x1, this is the point. How would you report this? x1 equals to 2, x2 equals to 3, z equals to 27 is the point of optima.